All right, well, good morning, folks. My name is Cameron Nixon, and welcome back to the discussion. Today is Tuesday, April 7th of 2020, and we've got a pretty broad, slight per SPC risk of severe storms from lower Michigan into Ohio and the Virginias, even a little bit of Pennsylvania. So especially because this is the pure state of Michigan's first chance for some supercells of the year 2020, figured I would discuss the setup that is causing that. So we've got a pretty long belt of northwest flow, which is a pretty intriguing setup for early April. This is usually something that you see giving this part of the U.S. setups more like later July into September. But we do have this pretty strong cutoff low that does remind us that this is still spring. And this has been kind of helping us stockpile our dew points over the last couple days. If I go to dew points, we can see that we largely have all of our moisture in place already at 12Z over much of the outlook area. That's a little bit different from most April setups where you get all that just-in-time moisture that may or may not end up working out. So we have that already. And let's take a look at our current surface features. We've got a remnant MCS from the overnight hours from northwest Indiana, cruising through Ohio into the Virginias. And my guess is this is going to reintroduce the risk of convection ahead of it, as it allows for some scattered forcing around this thing. We could see kind of like a little gravity wave here, I think, and toward the center of the system as well. We have a pretty washed out outflow boundary. I really don't think, especially with the synoptic forcing today, that an outflow boundary is going to be a play today, especially with how washed out it is. But you could already see a couple 57s in there, 58s, 56s, a little bit of 60s dews here. So we're really, dews are already filtering in. Again, this is really washed out. Our temperatures are only in the low 60s above that, but they're only in kind of the upper 60s, low 70s toward the southern end. So not really a well-defined outflow boundary here, especially probably because this was elevated and really did not have that many surface features. I think there's going to be two regimes today. One, any convection that develops ahead of this wave, especially off the higher terrain of West Virginia and moves from West Virginia into Virginia. And also with our main system, which we could track. Let's do some 500 millibar vorticity, a little bit of a CVA ahead of this wave. So it's going to kind of drift downward into this outlook area, and it's a little bit laggy. See, it doesn't really arrive into Michigan or off the coast of Lake Michigan by around 0Z. We could go, let's do some 850s. Got a pretty notable temp advection regime, both behind and in front of this warm sector. So I'm thinking that our low-level fields will generally strengthen throughout the day. We could go to 950 or 925 millibars, and we have this really, really gradual ramp up. But once we hit that kind of 0Z hour, we do have a little bit more of a pronounced troughing and a stronger speed max ahead of that as well. So our photographs and our shear profiles really will not change much throughout the day over the entire outlook area until around sunset. And we've got what's pretty characteristic of 2020. We've got this really strong upper level flow that has yielded some fast storm motions and better hail efficiency per these last setups as well. So this is not going to change very much throughout the day either, and really kind of provide a constant risk of hail and some semblance of a supercell activity over much of this outlook area. So we can look at, I'll address this Virginia's setup briefly, but that's not going to be my main focus today. We have, I guess, can break this down a little bit more. We already have kind of a dew point stockpile behind the Appalachians here into the Virginias. and especially as we go on toward the day. Might get a little bit more advecting in. I think the main player that would kind of halt a more significant threat is going to be downslope warming that occurs east of the Appalachians. You can see some of that going on. We have higher temperatures, especially east. We got these mid-upper 70s here, and especially those could climb throughout the day. So that's why I'm going to be using mixed layer cape on the Her, because this is usually a better estimate for a very well mixed high temp dew spreads days. So I can start at maybe around 22Z and go. I'll pluck a couple soundings below and above the warm front, and look at that temp dew spread. This is usually a damaging wind potential kind of sounding, but you do have a pretty nicely rounded hodograph with a lot of shear interspersed from 0 to 1. So these are going to be pretty good for supercells. A lot of upper level venting as well. So this is definitely a hail and damaging wind sounding. And go a little bit later, I'll pluck one north of the warm front this time. And you can see the shear elongates on the low levels, and it is very, very broad and kind of perpendicular to your storm motion. I've noticed these are pretty good for hail, and you have some pretty streamwise flow around the storm motion in the mid and upper levels. So generally pretty good for hail again, even if these are pretty high based. But I think the main threat could be damaging winds with these as well. So now that we got that one over with, what is going to be forcing our convection in lower Michigan into Indiana and Ohio today? What I noticed was, let's do 700. Let's do the NAM. Oh, no, sorry, they do have... what I noticed is that there is a little bit of discrepancy between the NAM and the RAP. No, it was 925. As to the degree of forcing for this convection later on, and let's do 12 hours and compare models. So we've got the RAP here, NAM here, and NAM generally has stronger wind fields. I'm looking especially just off the lake, and a little bit more confluent flow as well. RAP mixes that out as it usually does and kind of washes out that signal. So that's why the 12Z NAM 3 kilometer has a more linear solution for convection, and I'm wondering if that's because there is stronger forcing modeled on that. Huge differences in temperature too as I'm scrolling back and forth between these two, so that is non-negligible as well, and we'll discuss what that means also. But so we generally do have enough forcing to get convection with this, especially as it rolls off the lake into western and lower Michigan. So we can, let's do the main player, actually, let's stay on 925. The main player as to how much convection we'll get, and in some of our hazard types, is going to be this really hot 925 flow that the RAP has modeled. The NAM doesn't actually have this hot of flow modeled, especially nosing in here. So that's something to keep in mind. But what I've noticed is a very quick erosion of this, and you can kind of see that over southern lower Michigan, right around 0Z, and I can pull up, let's do 700s too, and you can see we have that ridging in temperatures around 22Z, but as soon as sunset hits, we get those colder temps filtering in. So this is going to help erode whatever cap we do end up having right around sunset, though. And again, as we remember, the 925 flow really started doing its thing after 0Z as well. So generally, our severe weather is probably going to be confined to a very small area. And I've noticed, especially if the RAP and even in the NAM come to fruition, our temperatures in the low levels are warmest in northern Indiana and northwest Ohio. And I think what that's going to do is once your surface cools overnight, it's going to inhibit much of a vigorous convection threat unless it's kind of driven by a lifting mechanism such as that whatever forcing mechanism or front is coming through here. So I'm thinking our best shot at a robust supercellular dynamics is going to be confined largely to Michigan, and especially around that sunset hour. And as soon as that kind of moves out of that region into the stronger or these higher, lower level temps, I don't think supercell mode is going to be favored much, and you're going to end up with kind of this congealed linear system capable of dealing especially damaging winds as you get into this area. So what in our kinematic fields is good or bad for supercells? Again, this 925 flow is going to really change things around the 0Z hour. I can pull up some HER for this because again, I'm going to like the mixed layer today. We have a little bit deeper of a mixed layer. I can show you how quickly these things, these ingredients are going to come together in Southwest Michigan. This is 22Z. We have a pretty supportive photograph already for supercells. We have decent low-level shear and especially 1 to 6 kilometer shear. We have a lot of that and upper-level ventilation. So very good hail sounding, and we do have that stout cap still there. This looks slightly convectively contaminated, but goes with pretty much everything I've seen so far. And a pretty decent temp to spread of about 10 degrees, leading to slightly higher LCLs. Notice our 3 cape is pretty low because we do have that intrusive cap here. But the main story, which I forgot to talk about, is, I believe NAM is the only thing that has this, our elevated mix layer above this capping inversion, which is very strong for this time of year, especially into this area. We have 8 degrees Celsius and higher, 8.5 per kilometer. So very steep lapse rates originating from out west and cruising over here. So if any storm does break whatever cap, this is that classic, if it breaks the cap, it's going to be really strong. And there's merit to that because we do have very steep lapse rates, and any updraft would have access to some pretty thick cape, as seen in this sounding right here. But cruise this out only 2 hours later. This is the magic 0Z hour. You can go in Southwest Michigan again. And you have a really lengthened 0 to 1 shear segment, coincident with that enhanced 925 millibar flow. And we still have pretty strong deep layer supercell kinematics. This is a very good photograph for long-lived robust supercells if they don't end up congealing. Very interspersed shear throughout a deep layer, and especially that low-level shear will allow for some pretty strong low-level meso formation, even though we do have slightly higher LCLs than normal, and some thermo issues to deal with. I don't know what this is doing because this is contaminated, Cameron. Why are you doing this? Let's go a little bit further out. There we go, we're a little bit better, but we still have that same general photograph shape, and you can see our subtle impacts of the evening hour rolling around. We have our shallow little inversion here. This hasn't really stopped much in the way of tornadic activity lately, so I don't think this is going to be a huge issue. But you could see our big story here is that cap erodes really substantially, and we improve our 3 cape too to something that is more manageable for low-level stretching as well. So I'm guessing our best shot at robust low-level mesos and perhaps tornadoes is going to be around that 0Z to 1Z hour in southern Michigan before things start getting a little bit too nocturnally inverted. This is again a contaminated sounding, so we can go a little bit ahead of this with those really warm 925s we talked about earlier, and just our general nighttime cooling. Even though our photograph is pretty good, so I'm expecting there's going to be some sort of window where things aren't completely congealed yet, that there still is going to be a pretty large hail threat as well after sunset. So again, I guess I can give a slight timeline. I'm guessing that in the hour or two before 0Z, when these things start forming off the lake, going to be mainly a large hail threat. And you could end up getting some isolated supercell structures, especially if you're using the wrap and less of the NAM with its stronger forcing. Is going to be a window for a tornado or two, perhaps strong. I hesitate. I believe didn't mean to do that, but I believe the ingredients are there for a briefly strong tornado kind of in this area. But I think that is a very unlikely occurrence, especially with the degree of forcing that we've seen that supercells may be competing, and no individual cell lasting longer than a couple hours or so. Other than that, brief tornado or two are definitely possible here, before mainly congealing and then running into that cap, which I can illustrate over northwest Ohio at around 2Z. And yeah, so really substantial low-level cap here, even though you still have some pretty good photographs with that. So yeah, I'll be interested to see what happens today, and as always, thank you guys for watching, and feel free to chime in with whatever feelings you have about today's setup. Alright, you guys, have a good one.